CloudDB, shaping your new normal.
Welcome everyone, wherever you are around the world, to the 2022 APEC OCI Days by Apaco UC. This is our first year having a dedicated OCI event, and it's our honor and privilege to run this event with the support of 15 Oracle user groups and Java user groups in the Asia Pacific region. Please remember to register to as many sessions as you can. This way, you will be able to access all the replays until June 15, 2022. The replays from yesterday's sessions will be uploaded in the next couple hours, and the same will happen at 24 hours of each live session. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, the ACE community, the DevRel team, and your main sponsors, Oracle Corporation and CloudDB. Now for today's session, Guardians of the Data, protecting Oracle database and backups from ransomware and malicious intents by Ron Ekins. Please feel free to make questions at any time by using the chat window in your right lower corner of the screen, and Ron will be answering all questions at the end of the session. If you have any issues during this presentation, any technical problems, please let me know using the same chat window, and I will try to help you the best I can. Now, without any more further ado, I'm going to leave you with this amazing session by Ron Ekins. Ron, the room is yours.
Oh, thank you, and welcome to everyone around the world. Hopefully I'm coming through nice and strong. So, thank you for joining me for my session of Guards of the Data, protecting Oracle databases and backups from ransomware and malicious intents. So that's me, Ron Ekins. I'm a Principal Field Solution Architect working in the Office of the O at Pure Storage. There's my Twitter handle, @Ron Ekins. I've also got an Oracle-themed blog, ronekins.com, where I try to create lots of interesting content every couple of weeks, so you may want to take a visit there. I'm an Oracle ACE Director and also a TOGAF Certified Enterprise Architect and Oracle Cloud Architect. So what are we going to be covering today? So here's my agenda. We will first of all get some definitions of what are malware and ransomware. Then I'll call upon my 30 years plus experience of working in the defense industry and aerospace about defense in depth and what this means for an Oracle environment. So think defense in depth and how we can protect our databases and our backups from malicious intent and ransomware. And then what else we need to consider. So that's the agenda. So let's start by defining what do we mean by ransomware and malware. So malware, and this is a definition from the National Cybersecurity Center, and the link's down the bottom, is malicious software which is able to run and cause harm in many ways. This could be locking your device or making it unstable, stealing or deleting or encrypting data, and this is really what we talk about when we think of ransomware. But also malware can take control of your device and use your computers against other organizations, maybe pointing the finger at yourself. Obtaining credentials which allow your organization's systems to be used in a way that they weren't planned. This could be causing the system to create phone calls or mining cryptocurrency. So if someone hijacks your computer and is using it against you or using it for things that you didn't design it for, that's what a malware attack's doing. Ransomware is a special form of malware. And it's about preventing you to use your data or the systems that have that data on it. So the definition says the computer itself may become locked or the data on it may be stolen, deleted or encrypted. Some ransomware will also try to spread to other machines on the networks, such as the WannaCry malware. So ransomware doesn't just attack one platform, one database, one application. The ransomware software, once it's in your system, will try to go around the whole network and infect as many machines as it can. reaching internally and externally. So we need to be aware of this. And there's the definition there and the link to the ransomware from the National Cybersecurity again. So I often get asked, ransomware, it's something that happens to other people. It's not really relevant to my business. And also, it's quite complex. Only a few people are doing this. It's state-sponsored. But the reality is, it's widespread. And it's actually very easy to develop your own ransomware solution. If you go onto the web, you can look for ransomware as a service kits. Very easy to use. They're not designed for computer engineers or people with master's degrees. Anybody that has a basic computer understanding can use a ransomware kit. Very detailed instructions. You define the rules that you want to use for the ransomware. So who you're targeting, what message you'd like to put up there, how much money you want to charge, what form of payment you're going to accept, and that's it. No scripting required. So the classic model is the author of the kit takes 20% revenue, and the perpetrator of the crime, it is a crime, takes 80%. The amount that they charge and the amount of the ratio of kit author versus attacker varies depending on the sophistication of the RAS kit. It's a service. It's a marketplace. These RAS kit providers compete against each other. So there's different price ranges depending on the sophistication of the tool. So what does a ransomware attack look like? So if you've ever been in a public space, you may have seen a blue screen of death. That's on the Windows NT side. And we see sometimes screens get hacked or go offline, and there is a message there with a BIOS message or an application failure message. But this was a ransomware message, and this is a screenshot from the Deutsche Bahn train timetable system. So this was public. So not just the internal users were aware of this and the organization, but actually anyone that was using the train network. So you have a choice now. What do you do with this ransomware information? Do you pay, or do you look for other ways of recovering against it? So Deutsche Bahn are a very big company, but it's not just big organizations that get attacked. Bangkok Airways with the Lockbit ransomware attack. We've had Northern Rail in the UK attacked. We see organizations which you think would be out of scope, like a school. And you think, why would someone ransomware a school? Well, the school has data. It was delivering all of its classes online during COVID. Without its IT systems, it was unable to deliver any classes. So the ransomware providers, they attacked the school knowing that the school had to pay to keep its lessons online. Also, exam results had to be shared with universities. So all industries in all countries are vulnerable for ransomware attacks. And even with pandemics going on globally, pharmaceutical industries and medical research institutions are also under attack. So everyone's up for grabs in the ransomware world. If we go back a few years, we would all thought ransomware is about production databases, and that's still true. Production databases are the crown jewels, but hackers are getting smart. They're looking for the easy wins, maybe systems that aren't as well protected. So the hackers are looking for your backups. What they know is if you have a production database which gets encrypted, you're going to go to your backups. That's going to be your first port of call. So they don't want you to be able to use your backup. So they're hunting for them. Hunters spend days on your network looking for vulnerabilities, understanding your layouts, what databases you have, where you store your backups. Are your backups encrypted? How often do you take them? Do you actually check the logs for it? They infect all the machines and they run scripts to gather the information, harvesting credentials, volume names, file system names, everything they can to use against you. So we used to say that this was a long time. They could be in your system hundreds of days before they attacked. So back in 2011, 416 was the number on average, the time it took for a hacker to expose themselves, to say, I'm doing something now, and to act. They're getting faster. They're getting better at it. They can harvest the information a lot quicker. So only a few years ago, 200 days was the common number bandied around. Now that's fallen to 24 days. In 24 days, after being hit by a malware attack, you could find that your data and your systems become operable. The people developing the RAS kits are getting more agile. They're able to change their scripts rapidly and develop new scripts that get around some of the mitigations we put in place. So it's not a one-time fix. We have to be on the game all the time. We have to be aware of how their attacks are evolving and making sure we're putting the right steps in place to mitigate those attacks. So as I said, backups are our last line of defense. So we need to treat our backups in the same way we would our production data. If your production database is encrypted and you're being told that if you don't pay, you're not going to get this encryption key, you're going to be looking for your backups. The term I like to use is pay and pray, because even if you pay the person that's attacking you, there's no guarantee that this key is going to work. Who are you going to go back to if the key doesn't work? You know, you are trusting that the process works, that their code is good, and they can actually recover from that position. And the time it takes to decrypt your system could be days, could be weeks. So all this time you're vulnerable, your services are down, you're losing revenue. You're not able to provide the service to your business or to your end users. There's going to be no guarantees with a ransomware provider this is going to work. There's going to be no SLA against this. There's going to be no service desk that's going to help you recover from this. You go to the screen, you normally make a Bitcoin or transaction to pay for your decryption key, and then you're on your own. So what can we do? We don't want to be paying Bitcoin to ransomware providers. So we need to think defense in depth. So going back to my defense days, I always used to like to visualize the onion, the layers, and this is where we think defense in depth. So first of all, we think policies and procedures and awareness training, physical security. Then we build upon that network security, host security, application security. And finally, what the hacker's really after is our data. So we need to think about data security. They're the layers. These are the things that we need to consider when we're protecting our data and backups. So let's take those one by one. Policies and procedures. So we start with the employees and the contractors that we're employing. User training and education. It becomes a little bit harder when you have external systems and external providers, but that's offloaded then to those providers for you. So it starts with education and awareness, good hygiene around data handling. Then we look at our physical security, maybe our physical site, security guards, guard dogs, fences, security zones, keypad access, detection cameras, remote monitoring, CCTV. All of those are good measures. But as we start working remotely more and more, these don't always work. So we may have a secure data center, but you don't need to be in the data center now to be able to get to your data. So network security, firewalls, intrusion detection systems, antivirus software, email scanners, all of these help. We also need to think about how we work remotely. Are we working in a coffee shop in a public area? Are we working in a shopping mall? Or are we in our home environment? Who's looking over our shoulder while we're working? Are we sharing a computer? Do we know who's on that computer before us and after us if we're doing this in a hotel lobby? Is there a camera watching as we're typing? So physical security, network security are all good. And they need to be the best practice we've developed over the last 25 years need to be adopted there as well. Then we look at our host security, and this is really our data professionals. This is where we really focus on. We rely on our security teams to deliver the network and the physical security. But as data professionals, we need to think about our database hosts. So host security. So harden your servers. Look about what applications you're running on those servers. Uninstall unnecessary applications. Apply the latest security patches. Only run required services. Look at applications and tools and code. Don't just go to Stack Overflow and download code. Make sure you know where it's come from. Make sure it's a trusted source, and only run the applications and tools you need for that platform. Wherever possible, use non-default ports. What we're trying to do is to make it as hard as possible. If our platforms get compromised, if they find a way into our system, whether that be from a USB stick being stored in a machine or someone opening up an email, we need to make sure that our platforms are as hard as they can be. So one way we've done this in the defense world is we don't advertise operating systems and versions. We don't want to give a hacker any clues about what the platform is. If you know as soon as you see a prompt that it's running Red Hat or Ubuntu, you're giving someone a clue. So let's just make it hard for them. Think about your application security, and the same things that we did on the host, we need to do the application. Security patches, latest updates. Make the application as secure as we can. In an application, we should only have access to the parts of the applications we need. Restrict access to the need to know principle. So you only provide application access and data access to the people that actually need it, and only during the time they need it. So on our platforms, we need to lock down our access and make it hard. So we have our databases, we have our backups. So sometimes it could be human error, it could be a malware, but also it could be a bad actor. We talk about malicious intent. So the malware may be scripted. It may be looking for our database and backup files, working out what we have, where they are, so it can run the encryption scripts against them. But also, it could be a bad actor. It could be someone that's a disgruntled employee that is looking to cause harm. So we need to make it hard for scripts and also for humans. So the best place to start is with Oracle ASM. So ASM, by default, makes it hard to encrypt. Most scripted attacks are based on file systems. ASM uses raw block storage. It's harder for malware and intruders to discover. If you're sitting on a server and you are trying to get in and out as quick as you can, and you have one platform which is using a file system, one using ASM, you're going to focus on the file system one. You can see the data files, you can see the backup files, and you can encrypt them really fast and get out. You don't want to be detected there. So ASM makes it a little bit harder. It's a lot harder to encrypt a file system, a raw file system, than it is a traditional file system. So use ASM. ASM filter driver also gives us another layer of protection. The ASM filter driver filters out all non-Oracle IOs, which could be either an accidental mistake or a malicious attack, which is trying to overwrite our data. So ASM and the ASM filter driver are a good foundation protecting our databases. Maybe something else you haven't considered is Oracle Data Guard. Most ransomware attacks are transferred server to server or by person. Maybe the ransomware hasn't impacted all our data centers. As the malware is working at a file system level, maybe the file system hasn't been replicated. So if we're using Oracle Data Guard, maybe our redo stream is going to be fine, and we're going to have a good standby because the ransomware hasn't made it over to the standby DR site. So we have a DR incident, we have a ransomware incident, and we can fail over to a clean standby database that hasn't been encrypted. So that may be a possibility. if your storage supports it, your primary storage platform, use storage snapshots. These provide the fastest method of recovering, that instant point-in-time recovery we can achieve with this. A storage snapshot is the fastest way of returning back to a known good point. If we're doing storage snapshots, we also need to think about our databases and application binaries. So this could be the Oracle home and application binaries supporting it. What we don't want to do is bring our database back. We start up the application and we realize some of the libraries have been compromised and the data gets encrypted again. So use storage snapshots to protect the whole environment. One thing that we see changing in the ransomware field is it's not everything that gets encrypted. So some people say, oh, we can tell if we've been hacked because our storage space will go up because we don't get the same data reduction as all our data gets encrypted. The encryption methods now are getting faster because they're only encrypting key parts of the database or data files. So they don't need to encrypt the whole data file and take days to do this. They can just make it unusable, get it to a point where you have to pay to get that recovered. So storage snapshots give us one level of protection. Moving on. I said, we want to make it as hard as possible. So I always recommend that you have off-array backups. So if you lose your primary storage platform, you have another set of data somewhere else, following the 3-2-1 method. AutoFS is a way of doing this. So we can use AutoFS to auto-mount a file system. So I've got a blog there and I'll explain that in detail, how to configure AutoFS on a Linux server. But what we can do is we can use AutoFS to mount and unmount the NFS file system for our RMAN backups during the RMAN process. So rather than having the directory there the whole time for our backups and making them exposed, we make it harder. We only mount the file system whilst the backup's taking place. To do this, install AutoFS. Create a map file and start the service. So here I've got my server. I've said there's my backup mount point and I've got a timeout. By default, the timeout is 30 seconds of inactivity, 5 minutes, 300 seconds. I've changed that down to 180, so 3 minutes. So after 3 minutes of inactivity, the mount point will unmount if it's no longer being used. So here I've just said I have 2 databases and they go into 2 different file shares. So I'm an intruder on my system and I think, oh, this looks like a platform that has some databases on there. It looks like it may have some backups. Let's go hunting for those backups. So either this could be a script or a manual person. Goes to the root directory and says, oh, there's a mount point or a backup. That's where the backups are. And traditionally, you'd go into that file share and you would see the files. I do ls minus la, get a long listing, and there's nothing there. However, when the RMAN process runs, if it uses or talks to the demo directory, in this case, the files are visible. So we needed to know where the files are stored. So we made it a bit harder. And if we go there, we can now see the data files and we can see afterwards, because that directory has been used, it has been mounted. And so after a period of time of inactivity, that will get unmounted. So we've hidden that. So primary platform, database servers using NFS and direct NFS to have off-array backups. That's a great level of protection. So now we need to think about what happens when we've got a rogue DBA or sysadmin or poorly defined RMAN policies. How can we protect those against malware? Yeah, utilize NFS storage snapshots. Take an NFS file system snapshot of your backup locations. Provide a read-only snapshot so we can have this as a protection against that rogue administrator that's deleting all our backups by going into mount or a backup demo and deleting the files. Or an RMAN policy that says after 2 weeks, purge. Maybe we want to retain them a bit longer in the event of a ransomware attack. So look at your storage platform, see if there's some software development kits or ways of scripting that, and include those in your backup scripts. So whether that be using REST APIs or command line interface or software development kits, you should be able to automate this and include this as part of your backup scripts. So I've developed a Python script, which I just have a one-line, pass some parameters to it to be able to take a snapshot on a pure flash blade. So I have my snapshots, and that's really good. I've now got a read-only version of my RMAN backups. One thing you may have not done or been aware of is you can actually use the RMAN catalog command to actually record. You have these snapshot directories. So catalog start with snapshot directory, no prompt, and then register that snapshot directory in your RMAN catalog. This is great. This means that now we can treat this read-only version of our backups in the same way in the other ones. The only difference is it's now protected from accidental deletion. We don't have to restore and copy the .snapshot into the file system. We can actually tell RMAN that it's the same as any other backup file. So we can do restore database validate, test the integrity. I would always advise before doing any database restore, take a snapshot of your primary platform, because what you have there may be better than your backups. Just your backup hasn't been, maybe you have been checking your backups, maybe they've been failing for a period of time. So always protect what you have before you try and do a restore. So validate your backups, make sure they're good, and then restore database. And as you can see here, I'm restoring from the .snapshot directory into my ASM location. I haven't had to copy it out of the .snapshot into the demo. I'm letting RMAN read it directly from the snapshot directory. Great. I've now got some different levels of defense. I've hardened my servers. I've got my primary platform protected by snapshots, and I've got off-array backups, and I'm protecting those off-array backups by using read-only snapshots. Read-only snapshots are immutable and can't be deleted by accidentally. Following the 3-2-1 principle, we need to actually have our backups in a third location. So we replicate those onto another storage platform. But what happens if our storage array credentials are compromised, or we have a rogue storage administrator? How do we protect against that possibility? Malware is good. We've managed to avoid a malware attack, but we have someone in our organization that is using our systems against us. Utilize your storage platform to do this. Speak to your storage vendor about whether they have the ability to protect the immutable snapshots. So even though they may be read-only, what if, as a storage administrator, you could delete those read-only snapshots? So we want to make sure that our read-only snapshots, if we need them, are available for our recovery. This could be against accidental deletion or on-purpose deletion. So we have our backups on our primary platform, we've replicated them, and now have safe node snapshots on my secondary storage platform, my secondary backup platform. The safe mode snapshots mean that once the .snapshot directory is deleted, it's not actually deleted. It's not deleted unless you speak to your storage administrator, or two storage administrators speak to the storage platform owner, the vendor, and they unlock it for you. So it gives us that added level of protection where the snapshots aren't either purged off over time or deleted on purpose. A few years ago, when we was having in-person conferences, I went to the Polish Oracle user group, POG, and I've got a t-shirt that says this quote, and you may have seen it before. Schroeder's backup. The condition of any backup is unknown until a restore is attempted. So really, this should be a part of our hygiene. We shouldn't just be doing annual tests of our DR strategy. We shouldn't just be doing ad hoc testing of our backups. It needs to be part of our daily routines. We need to understand where our data is, how it's protected, and what we would do in the event of a disaster. Are you ready for a ransomware attack? rather than thinking it's not going to happen to me. Think about, what if it happened to me? What would I do this afternoon or tomorrow? How will we react? Understand the impact on your business. Does your organization have some service level agreements in place? What are your recovery time objectives? What's your recovery point objectives? Does it meet your business needs and expectations? Were these set years ago and now you are a 24/7 organization? Do you have remote workers? How would they access the systems? The systems were compromised. Can you restore a single application in isolation? Are they interrelated? Do you know the interdependencies? How long does it take to restore a system? How long does it take to restore multiple systems if you do them in parallel and you have contention on your network and your storage platforms? All of these need to be factored in. If you're backing up data to the cloud, how long would it take to pull that data back? One thing I always recommend people do is, when you have your playbooks, your run books, and you understand what you're going to do, get them peer reviewed. It's too easy to write a document, and when you use a document, it seems fine. It's easy to follow, but does it work for someone else? So get someone else to test your process. Make sure that any step that is missing or not clear is updated. Treat your run books and all your processes the same way you would code. When you make a configuration change on the platform or the application, the documentation gets updated. Maybe put it under configuration control with all your other documents and code updates. So it becomes a living document rather than something which was produced at the time the platform was created and then lives on the shelf. So get someone else to test it, review them periodically, and understand system interdependencies. Because as new applications get installed, you need to understand the impact. You may not be able to restore an individual system. Talk to your business and application owners. Are there SaaS solutions? Are you interfacing with those? Is it even possible to roll back one application in isolation? We need to look at the aerospace industry. We need to look and have the same disciplines that pilots have. As data professionals, let's look at other industries about the way they work. So as a pilot, they spend lots of time in a simulator before they ever go in the air. But even once they are a pilot, they have training days. They use the simulator to play out different scenarios. We should be doing the same. They also have a document called the Cockpit Companion. The companion helps the pilot not to have to think in the event of a disaster. A major incident, they've been trained, they've experienced it, they've gone through different scenarios in the simulator. But the Cockpit Companion has detailed information step by step of the way that they should behave. Wouldn't it be great if we had that as data professionals? So validate our backup scope and integrity. Perform regular restores and clones. Maintain the data recovery procedures. Seek document approval. And when anything changed, get notified. Changes in the infrastructure, changes in the application's configuration. And finally, simulate disasters, simulate incidents. Take these to your audit teams and test, test, and test. And finally, validate your backups. Validate the integrity of them. One way of doing this is to perform regular restores, but also database clones. It's a good way of exercising your backups. If you can use those to clone environments, you know that your processes are good, your data backups have good integrity. We're not in it on our own. We are a team. So data defense in depth requires a team. And we all need to work together. So whether that be your Linux administrators, your storage administrators, your SREs, DBAs, application developers, we're all in it together. So together, review and understand our risk to malware and other threats, and adopt a multi-layered approach to data protection to give us our best chance of data protection. So now I'm going to take some questions.
Thank you so much, Ron. Excellent presentation as always. Just checking if anyone here has any questions. Remember, you can post them in the chat window in the right lower corner of your screen. I'm just waiting for the user groups to let me know if there's any questions coming from the Facebook side. And I'll let you know in just 1 second. In the meantime, Ron, thank you so much for taking the time to share your knowledge and experience with the users and the community in the Asia Pacific and globally. And especially, I think so, it's early morning for you over there.
It's not too bad. I'm pleased, and it's an honour to be presenting at your conference today. So thank you for the opportunity. If anyone wants to see the code that I use to do my my Python script to do the snapshots, that's available from my website, ronekins.com. And also there is a public GitHub repository, which is linked from there. So there's code examples, which you can have a look at. And as I say, there's blogs on how to configure AutoAFS and other ways of protecting our data and databases.
Fantastic. Thank you so much, Ron. And I was told by the Facebook side that that's no questions, and looks like no one wants to make questions on this side too. That means if you're watching the replay or you don't want to make questions right now in a public forum, you want to do that privately, please feel free to contact Ron directly through LinkedIn or Twitter or to his email that's in the presentation. You can take a look when you watch the replay again, and he will be able to answer any questions you could have offline. Other option is also contacting me or anyone from Apaco UC, and we can relay your questions to Ron.
Thank you. Yes, and yeah, it's not the easiest thing to talk about, data protection and ransomware. Not if you ever had the misfortune to be attacked, it's not something you necessarily want to share. So happy to take any calls offline. Fantastic.
Saying that, thank you again, Ron. Thank you so much, everyone. Please take care, everyone, and be safe.
Thank you.
This is the last session of today of the day, and we have 6 more tomorrow before we end this conference. Thank you so much, everyone. Bye-bye.
Bye-bye.